All, welcome to LTX classes. In this class, we shall deal about the Indian Express important explainer article, which deals about what is ISRO's poem platform. Okay, poem platform. So we shall see first of all what is the meaning of poem. Actually, it is an abbreviated form. We shall discuss in length. Okay, where we shall be see this. We shall be seeing this in our GS3 Science and Technology. Okay, GS3 Science and Technology, where we shall be covering the whole scenario from the background. Okay, yes. Then see the article is being done by Srinivas. Okay, we shall see this article. Let's have this. Okay. First of all, we shall have this question, and at the end of the class, we shall deal the approach, and you have to write the answer and you have to post in the comments where we shall be reviewing the answer. And in this pace, you have to regularly practice one answer, and it shall definitely help in your capacity and skill building. Okay, have this question: ISRO's recent poem experiment, okay, POEM, poem experiment, has pushed up our opportunities to further the space missions. Explain. Where I have asked for 10 marks, means it should end with 150 words. Okay, have this orientation in your brain, and with this orientation of question, have the class from the basics, and at last we shall deal the thing how we have to deal the answer, and you have to post in the comment boxes. Okay, have this class. First of all, what is ISRO? ISRO means Indian Space Research Organization. Okay, it acts as the nodal agency. Okay, nodal agency means the head agency. Sir, for what? This is about to do space research. Space research. Okay, yeah. And see, this accredits with one of the best organizations in the world regarding space research. ISRO holds that record too. Okay, so ISRO acts as nodal agency for space research. Sir, for what? Space research have lots of applications. Lots of applications in the sense, see, where we shall get few of the services like communication, right? Communication, and see, we shall be getting the services of navigation, right? Communication means, see, passing of information from one place to the other, and navigation means where we shall be seeing the areas through maps and everything, right? So navigation experiments and communication related things and everything shall be dealt by the space research. So to cater all these things, ISRO does, what is that? Okay, they prepare satellites. Satellite. Sir, satellite for what? Satellite is an object where it is placed in the space to transfer communication. See this one. Let's have this. This being the earth, we shall place satellite here. So if satellite is placed here, the range of the satellite could be like this. Clear? So from this, there shall be at the ground level, we can observe the antenna. Antenna transmits the signals, and antenna receives the signals too, from where it shall dispense the information that it is getting from the satellite that is on board in the air. Is this fine? So satellite shall pass on information which it is collecting from the earth. Are you getting? So if a person stands here, and if he wants to speak this person from here, let's take person A is in India and person B is in UK. So simply he can see, what if he want to speak with person B, the signals shall be transferred to the satellite, and from where it is being transferred to the person B. So communication things shall be dealt by the satellites which cater to the services of communication. Okay, so are you getting the importance of satellites? Then who will place this satellite in that space, and why shall satellite should stand on that space? See this. So to transfer any object from the earth to the space, we shall require some medium, right? We shall require some medium. Sir, then what is this medium? This medium being called as rocket. Okay, so this medium is called rocket. Sir, then what are the rockets we have? Initially, we used to have the sounding rockets. The sounding rockets. After that, we are seeing about SLVs. Sir, SLV means satellite launch vehicle. So are you getting? So this is where it shall cater the satellite needs and it acts as the launching vehicle. Okay, so that is called rocket, and after that it has further improved to PSLV. Okay, so PSLV means polar satellite launching vehicle. Okay, polar satellite launching vehicle. Sir, what is the meaning of polar? Polar means it is an orbit. We shall be checking that, don't worry. Fine. So PSLV means polar satellite launch vehicle. Actually this have this credit of being called as the workhorse of ISRO. Workhorse of ISRO. Sir, workhorse means where it actively indulges in the taking of satellites from the earth to the space. So this holds the credit of being called as the workhorse of the ISRO by having very little chances of failure and there are high chances of success. So this is being called as the workhorse of ISRO, and the later upgradation being GSLV. Okay, so GSLV means geostationary launch vehicle. Okay, so we shall be checking all these vehicles and everything. So we got this. There should be some rocket where it should carry the satellite, that and it has to be onboarded, and this has to be carried from earth to the space. Then sir, in space who will hold that? Just have this. See, you can get the doubt, sir, earth holds something force that is called gravitation, right? Gravitation, and it's being called the gravitational force. Gravitational force means earth as a huge body have great attraction power. Gravitational force means great attraction power, right? So great attraction power. So this great attraction power actually drags every being that is within the sphere of earth. See, if this is earth, if I place anything, let's take some 10,000 kg product, some 10,000 weight product, definitely it has to fall down. Definitely it has to fall down. That dragging force is called gravitational pull of earth. Okay, this gravitational pull of earth holds everything and drags everything towards it. Then sir, then who will place this satellite? The rocket will place satellite. Sir, at what cost and at what altitude? What altitude? Altitude means height. So scientists, after various experiments, got something called as orbits. Something called as orbits. Sir, what is the meaning of orbit then? Orbit is an imaginary line where the satellite rotates itself by not falling into the gravitational pull of earth. I said, what is that? Up to the sphere of earth or up to the influence of earth, it can drag any item into it, right? So first of all, let's take, if its drag power is up to 150 kilometers from the earth, if its dragging power is up to 150 kilometers, so every object that is placed below 150 kilometers can be dragged towards the earth without any force, right? Without any pull or push, right? So then what if a satellite is kept at the space of 160 kilometers? Then what it holds? It cannot fall into that gravitational pull unless some external forces acts in. So let's take this. One rocket was used and it placed the satellite at 200 kilometers from the earth. Then what this satellite will do? This satellite can rotate around the earth without any deviations. Have this. See, all these are basics to understand the ISRO's POM orbit. Okay, see, a satellite experiment. See this, what I said. See, this being the earth, if something is placed at 200 kilometers distance, 200 kilometers, and this being the, let's take this being the satellite, and from where it shall rotate around the earth. Okay, rotate around the earth. Sir, up to what? Up to what means, if let's take, if any large destruction happens to it, or if any object meets it, definitely it gets crashed, right? Until that time it actually rotates into that orbit of the earth, and it shall transmit the information. This is what is the whole experiment that is being done at the level of space, right? So let's look at the satellite that we have used in this. So what is the article? The article is about POM, right? Sir, then what is this POM? POM means, this P stands here polar. Okay, O means orbit, polar orbital. E means experimentation. M means, that is the module, polar orbital experimentation module. Okay, this is POM. So we have to see polar orbit, and we have to see the rocket also, PSLV, right? So actually this polar means PSLV, polar satellite launch vehicle, orbital experimentation module. Okay, the original full form of POM means PSLV, orbital experimentation module. So we shall check the PSLV in structure, and after that we shall check the different orbits around the earth. Okay, check this. This is being the vehicle of the satellites, which is of PSLV. Okay, PSLV, polar satellite launching vehicle. See here, it is called the strap-ons. This is the whole body of rocket, and these are strap-ons. And here let's take stage 1, stage 2, stage 3, stage 4, and after that, see, stage 4 includes the payload also. Payload means actually what we are carrying. We are carrying this satellite, right? So satellites are placed in this stage 4, and stage 4 has some special inbuilt feature, and this stage 4 is very important to understand the present article. So first of all, let's have this. Sir, what has to be required for a satellite for its movement? See, a satellite requires a thrust. Satellite requires the thrust. Thrust means a big push that it requires. So then who will push this whole thing? So all these are being pulled by or pushed by some fuel. Okay, fuel is required. Actually, satellites work on the principle of Newton's third law of motion, right? Newton third law of motion. Under the third law of motion, what we shall check? Under this, we read as, for every action there is an equal and opposite reaction, right? So that opposite reaction is being the push of rocket from the earth towards the space. So then what is that? Every action, that action is thrust of that engine by using the fuel. So for every rocket launch we require huge amount of fuels that is completely different from the fuels that are being used in the present day vehicles like cars, bikes, everything, right? So these are aviation fuels. These are completely different. Let's say take this stage 1 is of fuel only, that fuel being the solid propellant, solid one. Okay, here we shall check the solid fuel, and in stage 2 we check as it being the liquid fuel, and stage 3 is also of solid fuel. So one solid, one liquid, and next one is solid. So then what is stage 4? Stage 4 consists of different onboard experimentation modules. See, till now what used to happen, and we shall get that till now what used to happen, and after with this recent ISRO's experiment, what we can see in near future, we shall be checking that in the article. Don't worry, let's continue this. We shall check different orbits so that you will be getting some basic understanding regarding the orbits. Okay, so there are various orbits around the earth, various orbits. See, everything should be learned according to the questions asked in the UPSC, and we should acquire the basic minimum knowledge so that in remaining further articles we just no need to check further thing. So in that way we have to learn the things. Orbits, various orbits. Under various orbits we shall check low earth orbit, low earth orbit. Clear? Low earth orbit. Under NASA and ESA definition, see, more than 160 kilometers, okay, more than 160 kilometers to 2000 kilometers, 160 to 2000 kilometers, it is called low earth orbit. Okay, low earth orbit means from earth the distance is very low, so it is called low earth orbit. See, actually for low earth orbits we use the earth observation satellites. Okay, earth observation satellites. Sir, okay, we shall get why earth observation satellites are fixed at low earth orbit. After that we are having medium earth orbit, low earth orbit and medium earth orbit. So in medium earth orbit we shall check from 2000 kilometers, and all these are imaginary lines only, right? 2000 to 35,786 kilometers. Okay, 2000 to 35,786 kilometers, it is called medium earth orbit. And the other one is, see, high earth being geostationary orbit. So in geostationary orbit and geosynchronous orbit, it is of more than 35,786 kilometers. Okay, 35,786 kilometers. All this information is from European Space Agency and NASA, so we can rely on this information and these distances and everything. And see, in geostationary and geosynchronous orbits we shall place the communication satellites. Sir, why communication satellites are placed at such a distance and the earth observation satellites are placed at a low distance? Check this. Take this as earth and see, if I place, let's take this as some 200 kilometers. Okay, 200 kilometers means low earth orbit, where I shall place the satellite of earth observation. Okay, can you imagine the satellite radius or influence can be up to here, right? So let's place any other satellite which is in geostationary orbit. Let's take this is of a geostationary orbit. Okay, 35,786 kilometers, and I named it. See, this is earth observation and this is communication. So let's have this influence. So the influence could be much larger. If any object is placed at a large distance, the radius and focus of that communication satellite or that satellite extends to a much greater extent. So similarly situated any satellite that is at low altitude definitely have the huge focus but at small distance. See, but the communication satellites actually extends its influence. So for every person who wants to communicate at large distance, wants to place the communication satellites at 35,786 kilometers altitude, right? But Earth observation requires a huge contact of information. Okay, a thorough information is being passed and it can thoroughly check Earth observation satellite. Sir, in Earth observation satellites, what we shall check? See weather forecasting, see very any minerals that is located below the Earth, or any fishery or the agricultural related, everything comes under Earth observation satellite. So, and all these things should be placed in low Earth orbit so that the orbit can have high focus and the orbit can rotate the Earth at lesser ease. See, any orbit, any satellite which is placed in low Earth orbit, it can rotate the Earth within actually the time of 1 hour, 2 hour, 3 hours, as such within hours it can do. But if any satellite placed at geostationary and geosynchronous, we shall see that would take around 1 day to keep the whole rotation. Okay, so we shall get what is this, and see, this is geostationary and geosynchronous and this is low Earth orbit, right? So first of all we shall check what is geostationary and geosynchronous. Geostationary, first of all geostationary and geosynchronous. First of all, what is synchronous? Sync means which goes exactly intact with some other object, right? So let's take, if this is Earth, let's take this is equator. So a geostationary orbit rotates, have this orbit around this, okay, around the Earth in this way, and it shall rotate in this way. Okay, so any geosynchronous have this sync with Earth rotation. Earth requires 23 hours 56 minutes, right? So every geosynchronous placed satellite, every geosynchronous linked space satellite actually rotates at the same speed and at the same time, right? So satellite requires 23 hours 56 minutes to make exactly the same rotation around the Earth. So with this, what we can see, if any object, see, if satellite passes around the, okay, for example, see, if that satellite passes around Delhi, passes around Delhi at every day at 12:30 p.m. in the afternoon, so you can check that satellite passes exactly Delhi at 12:30 p.m. So if we carry this is called geosynchronous. It have sync with the geo means Earth, right? So then what is geostationary? Geostationary satellite means if any satellite that is placed exactly at equator, if any satellite that is placed exactly at equator at the distance of 35,786 kilometers, then it is called geostationary orbit. Okay, sir, then geosynchronous means geosynchronous includes geostationary plus other areas. So equator is, we shall check as 0 degrees, right? Equator is something as 0 degrees, but up to some inclination of 10 to 20 degrees. Let's take this is 20 degrees. So every satellite that is placed between 0 to 20 degrees inclination from like this. So let's take this black one. This is the scale, and this is 0 degrees, and this is up to 20. So up to 20 degrees inclination, if some orbit is placed, it is called geosynchronous. If it is placed exactly at equator 0 degrees, it is called geostationary. Okay, so geostationary satellite and geosynchronous satellites require 23 hours 56 minutes to make a single rotation around the Earth and to communicate it. So we shall see this, okay, as the geostationary and geosynchronous orbits have huge extents of sphere. If we take at least, okay, let's take normally some 3 to 4 geosynchronous placed satellites can cover the communicated information around the Earth in toto. Clear? Are you getting? So that is the sphere of extension or influence of any satellites that are placed in geosynchronous, right? So we shall check now. We have checked what is GSLV and we shall check what is PSLV. PSLV means polar satellite launch vehicle. So then what is this polar orbit? Polar orbit means what we say polar regions as north and south, right? So if any orbit is like this, if any orbit is like this, from north to south, from south to north, it is called polar orbit. Polar orbit. So if any orbit rotates from north to south, it is called polar orbit. If any satellite rotates from west to east, means at the inclination of equator 0 degrees, it is called geostationary geosynchronous. So in PSLV, polar or sun synchronous satellite vehicles can be seen with this. Okay, sun synchronous polar vehicles. Clear? We got everything background information to understand the present article. Then we shall check what is this ISRO's PSLV orbital experimentation module, or simply POEM, POEM. We shall check this. See, we have checked that PSLV contains 4 stages, right? First stage is fuel of solid, second stage is of liquid, and third stage is of solid again, right? So then what is the fourth stage? Fourth stage contains the satellites, right? So it is like on board which carries the satellite and remain in space as space junk, means without any positive benefits to earth or without any positive benefits towards the satellite also. The fourth stage till now, used to act as space junk. Then what we are doing right now, we just want to utilize this fourth stage also as for what? To make it as an orbital experimentation. Orbital experimentation. Are you getting? From now we just want to use this fourth stage to conduct some experiments as stabilized platform. So for future explorations, this fourth stage can be clearly used to get some more information from the space. See, any information, any minute information regarding the space is very important for our future experiments, to not only to India but to every other country. So ISRO has come with some stabilized platform to use that PS4, right? So where here, let's have this. So in this POEM, to maintain that stabilization platform, it carries the dedicated navigation guidance. So until now it is used to act as junk, so that's why we just don't want to bother about its movement. But when we just want to use the fourth stage as the experimentation module, we just have fixed the navigation guidance where we shall be checking the path, the behavior of that fourth stage, and in future we shall come with some new experiments that are being carried from this. Clear? So it carries navigation guidance and control system. So from Earth we can control the movement and the behavior of the fourth stage. For what? This would act as altitude stabilization. Altitude stabilization. Altitude stabilization means, I said, up to 160 kilometers it can withstand. Okay, if something crosses 160 kilometers, it can withstand against the gravitational pulls. What if the space junk comes into 150 kilometers? It can, see, Earth can drag down that space junk, right? But now as we want to increase the use of the fourth stage, we have fixed navigation guidance and some thrust controllers. These thrust controllers would act as, see, provide some extra push up when it comes down. If anything comes down, if that fourth stage comes down, this thrust controller switches on the some thrusts and it would gets up. Okay, so it would gets up. Let's take this. This is 160. If that fourth stage comes down, immediately there would be some thing, right, that is called thrust controller, and this thrust controller would stabilize and this pushes up above 160 kilometers to maintain that stabilization. So to have this thrust, and we are using right now the helium thrusters. Okay, the helium thrusters, where it would provide the actual stabilization that is required, and for guidance, for movement, everything what we are using, we have we have mounted something that is called solar panels with that. Solar panels, where it gets energized from the solar heat, solar panels, and with lithium ion batteries, where it provides extra benefits to that fourth stage. So I think you got this. All this is related to use the fourth stage very wisely and to have this clear. So yes, ISRO have done very tremendous job, and it has and it is going to use this. And yesterday actually it has placed 6 satellites with PSLV launch vehicle. Fine. So and in that we are carrying the foreign friendly nations satellites also. Okay, so this is all about ISRO's POEM platform, and there are a lot of chances that UPSC might ask questions, or in examination mains point of view also we can do something that is related to experimentation things in mains answer writing. See, let's have some question regarding that, and we shall provide some approach also. ISRO's recent POEM experiment has pushed up our opportunities to further space missions. Explain. So initially we have dealt the question, right? So let's have the answer for this. For every question it should have some intro, right? Some introduction should be very crispy, and it should hit the bull's eye. Okay, so it should hit the bull's eye means we have to directly start from the POEM experiment. POEM experiments is being PSLV orbital experimentation module, from where ISRO tries to want to use the PSLV fourth stage as expand the future space missions and to conduct some experiments in the space. In this way you have to directly hit the bull's eye, and after that you have to write the body, where in body we shall deal all the things related to that. Okay, so the activities that can be done by using POEM experiment, you have to write in point way 1 2 3 4 as how it helps. Okay, POEM experiments done to do stabilization experiment, and it carries some polar modules and everything, and you shall be doing, and it provides some extra thrust by using helium, you should write. And after that, how next should be how POEM helps further missions or future missions. So some future missions being manned missions, right? Manned missions or Mars missions or moon missions, from where we have to carry these PSLVs and we shall use that, right? So in this way, how POEM helps? POEM actually right now does the stabilization experiments. If it gets success, then it can provide the long thrusting range and the long communication range, even in future if any satellite crosses the near distance of Earth, means if it enters into any other celestial orbit, it can have the communication platform on board it, and where, see, the second one, it can clearly observe the space junks that are coming towards it, and it can also protect the satellite that it has launched, right? So all these things, how POEM helps the further missions. And in conclusion, we have to write India is doing a lot great of experiments in the space sector, where it has provided the real-time application knowledge also, and it has showed path for even the developed and developing countries too, and it tries to enhance the space knowledge that is existing in India. In this way you have to conclude, and with this we have come the 150 word. If you organize the answer in this way, definitely you could get more marks from these science and technology questions. Okay, yes, so I think we have pleased you, and you have got some enhanced knowledge from our class, where we have covered from basics and towards the relevance of UPSC only, and this series shall continue. Please subscribe if you like the video. Hit the like button and please do comments where we'll get some resonation out of your comments. And my main intention motto is to, you have to write this on paper and you have to post that in the comment box where we shall be reviewing. Thank you.